3.7 Angle-Side Theorems. This theorem states if two sides of a triangle are congruent, then their base angles are congruent. Okay, the base angles of the triangle must be congruent if the two sides of the triangle are congruent. Okay, what this is saying, if you have an isosceles triangle, okay, remember isosceles means two sides congruent. If two sides of the triangle are congruent, then the base angles must be congruent. They're the base angles right here. Okay, to make this a little bit shorter, because it will be a reason for proofs, we're going to say if sides, draw a triangle, mark the two sides congruent, then angles. Draw another triangle, mark the angles congruent. Okay, this will be a new reason for our proofs. So we have to look for it when we're given angles are congruent or sides are congruent. The other thing that works here, the converse is also true. Remember the converse is when you switch the if and the then. So that means I'm going to say if angles, then sides. Okay, so the first proof, we have AB congruent to BC. Let's go ahead and write that down. AB congruent to BC. Once I have two sides congruent, I can go ahead from the two sides congruent. The angles will also be congruent. Angle A is congruent to angle C. And the reason for that is if sides, because in this case we're starting with the sides, then angles, we end with angles right here. Okay, looking at the next example, here I'm starting with the angles. So I'm going to say angle A is congruent to angle C. Because I have the angles congruent, I can now go ahead and say AB is congruent to BC. And my reasoning here is going to be the converse of the first one. If angles, here we're starting with angles, then sides. And that's it. Okay, let's look at these little notes really quick. An isosceles triangle, the angle bisectors of the vertex angle is also the median and the altitude. We talked about that a little bit last time, but if you have an isosceles triangle, okay, and you have an angle bisector going through this vertex, it's also going to be the median, which means median means midpoint, and altitude is perpendicular to the opposite side. Okay, looking at the next one, if a triangle is equilateral, remember equilateral triangle is going to be all equal sides. The triangle is also going to be equal angular. So if we have an equilateral triangle, it's also going to have all congruent angles as well. Let's look at the first example. First example deals with algebra. We have to find x and the shortest side length. So because it's an isosceles triangle, it's a little bit turned. Here are the two sides that are congruent. So here are the two angles that will be congruent as well. This angle here and this angle here. Okay, since they're giving you all three angles, you could always add all three and equal them to 180. But this way might be a little bit quicker, so we'll get the answer a little bit faster. Go ahead and set that up. Okay, we're going to subtract 3x to both sides. We have 35 equals 4x minus 1, add 1. 36 is 4x, divide by 4, and we get 9 is x. So I found x. We also need to find the shortest side length. Okay, so for the shortest side length, the opposite angle is going to be across from the shortest side length. That's the shortest. So if I have this picture right here, and say I have 61, 60, and 59, okay, the smallest angle is going to be across from the smallest side. So this right here is going to be the smallest. Here's my largest angle, 61. So across from it, this will be my largest side. And then 60 will be in the middle. So across from the smallest angle will be the small side. Across from the largest angle will be the largest side. So if I plug in the 9 for all three, go ahead and do that now. Okay, I plugged in the 9 for every side right here. 4 times 9, 36 plus 20 is 56. So we know this angle right here is 56. 7 times 9 is 63, minus 1 is 62. And 3 times 9 is 27 plus 35 is also going to be 62. Obviously, these two angles were the same because these two sides were the same. So the shortest side length has to be across from the smallest angle, which is right here. So the shortest side length has to be AB. Shortest side is, in fact, AB. Okay? If you were given something like this and they asked you to find the largest angle, so say we have 3, 4, 5, the largest angle will be across from the largest side. So this is the largest side right here. This angle, we'll say CAB, angle C is the largest, and B, because that's 3, that's going to be the smallest. Okay, that always works with triangles. Next two examples are two proofs. So let's look to see what we have here. We have CE congruent to DF, BD congruent to GE. So right now I have CD congruent to DF. I have BD congruent to GE. And I have BD is perpendicular to CF. So BD is perpendicular to CF. And the measure of angle 2 is 90 degrees. Okay, I want to try to prove AC is congruent to AF. So we're going to start off with a kind of a tricky one because I have to prove this whole side is congruent to this whole side. Well, you might be thinking addition. I'll have to add AB and AG, it looks like, but I cannot do that because I don't have AB is congruent to AG. But what I can do is find angle F is congruent to angle C, and then do if angles, then sides. So if you want to start this one off yourself, go ahead and try it. If not, wait and we will do it together. So let's start off with my first side here. I have CE is congruent to DF. So that is this entire piece with this entire piece here, DF. I'm going to probably need to get these two triangles congruent because I need to prove the two angles congruent by CPCTC. So, if CE is congruent to DF, I need to subtract something. If I took out this DE, I have left CD and EF. So I first need to write it down. DE is congruent to DE. Okay, something's congruent to itself. Hopefully you're staying reflexive. And if I take out the DE in the middle, I'm left with CD congruent to EF. Okay, and that is going to be a side of the triangle that I need. Okay, BD congruent to GE. I know that I have got to have an angle in between, so I'm going to write that a little bit lower. CE congruent to BD congruent to GE. That is going to be a side. Okay, and then I need to squeeze in an angle here. Well, I have BD perpendicular to CF. Okay, which means what do perpendicular lines form? They form right angles. BD is here, CF is here, so angle 1 is a right angle. Okay, I also have the measure of angle 2 is 90. Let me underline my givens. Okay, what do I know about a 90-degree angle? Well, it's also going to be a right angle. If I have both of these being right angles, I can say angle 1 is congruent to angle 2. Now I have my A. Looks like I'm proving these triangles congruent by side angle side. So I have triangle CDB is congruent to triangle FEG. CDB, FEG, remember order counts. Once I have the two triangles congruent, now I can say the angles are congruent. And if I have the corner angles, then I have the larger side across from them. So now I can say AC is congruent to AF. And that ends my proof. Let's go back and number everything. I already have 1, 2, let's see, this one's a lot of steps. 8 steps, I think that is our record on proofs. And let's go ahead and write them up here. All right, number 1, how do I know that something is congruent to itself? Because of the reflexive property. Number 2, how am I going from a larger segment to a smaller one? Well, I'm subtracting. Step 3, how do I know perpendicular lines form a right angle? Because I know the definition of perpendicular. 4, how do I know that 90 degrees is a right angle? Because this is the definition of a right angle. 5, if I have two right angles and they're congruent, I'm going to say all right angles congruent. Number 6, how do I know the two triangles are congruent? Because of side, angle, side, it says right here. 7, once I have congruent triangles, I want to say parts are congruent, so I'm going to say CPCTC. And last but not least, our new reason here, going from angles to sides, I'm going to say if angles, then sides. And I'm done with my proof. All right, the last one, example 3. This one you really have to look at because we have to try to figure out how we're going to go from AB and AD. So what we have are these two. AB is congruent to BC, and we have AD congruent to EC. Okay, what we're trying to get is this triangle here and this triangle, but then think about it because we have to try to get angle 3 and angle 4 at the very end. Okay, so what we're going to do is we're going to try to get these two corner triangles congruent, the ABD and the CBE. Okay, so we can go ahead and do that with if sides, then corner angles right here. So if AB is congruent, angle C will be congruent to angle A. Then we have an SAS. Once that's congruent, I'm going to say BD, congruent to BE. And then if sides, then angles. So go ahead and start with your two givens. All right, so what I have here is two sides. I need to try to get an angle. Because I have this large side, AB, I can go ahead and say angle C is congruent to the side opposite BC is angle A. Okay, so this is going to be my angle. I have a side. And I also have this one too. AB is congruent to BC. I'm going to write it again just so I have all three kind of in a row. I have side, angle, and side. Okay, once I have it, I can group it and now say that the triangle ABD is congruent to triangle CBE. Okay, remember order here counts. If I'm starting with A, BD, I must start with CBE. All right, so easy way to do this now is since I have the triangles congruent, I can now pull out BD is congruent to BE because if I have this side and this side, I can get the angles across from them. So I can say angle 3 is congruent to angle 4, and I'm done with my proof. So I have 1, 2, 3, 4 steps, and I'm done. Okay. Remember, I had to get the triangles first in order to get parts of the triangle congruent by CPCTC, and then I have if sides, then angles down here. All right, so reason 1, I'm going to go with if sides, because I'm given the sides, then we're going to go to angles. If sides, then angles. 2, SAS. 3, CPCTC. and 4. Here we're given the sides. If sides, then again 2 angles. If you wanted to put this as 1 again, that would be totally fine. That you would only have 3 steps because you're using this one twice. Alright, I'm sorry this one was so long. I hope you stayed with me and have a good night.